Hey everybody, and happy Tuesday. So here on the screen you can see we've got our Chapter 5 flipbook. So now we don't exactly have a flipbook right now because, from home and everything. So you can either make one, if you have 3 pieces of paper around, construction paper or printer paper or even notebook paper if you have to, you can do that. Or if there's some alternative way you want to keep track of all this information, just write it down in a notebook, keep track of it in a note or a document on your computer. Whatever works for you, just make sure it's all in one place. We're going to be a little loose on format for this right now just because, present circumstances. So, this is the titles for your Geometry Chapter 5 flipbook. We've got, here are the 5 pages, we've got our trig functions, inverse trig functions, special right triangles, law of sines, and law of cosines. The first page there, trig functions, is what we're going to put stuff in first. Speaking of, here we have a familiar friend, tangent. So this is our first trigonometric ratio. So the whole point of today's lesson is going to be that we need more of these. But for right now, we've got tangents. So in whatever format your flipbook or information gathering device is going to be, put this into your flipbooks. We've got that tangent is a ratio that converts from angle to slope. This should be very familiar. This is the entire point of all of Chapter 4 as we've gone up to it so far. So we've got tangent is equal to our change in y over tangent x, but also tangent of theta. Remember that little symbol right there that looks like a 0 with a line through it is a theta, T-H-E-T-A. That represents angle. It's a variable that only ever represents angle. We could put an x there, but x can refer to side length or angle. Theta can only ever refer to angle. And we can say the tangent of theta is equal to opposite over adjacent, which if you want to know what those look like, you've got that over in that diagram right there on the right. So put this in your flipbook. If you need to pause, go ahead and pause right now. And then we can move on. All right, so here we are in Chapter 5, and you might be wondering, what happened to Chapter 4? Well, we finished it. Chapter 4 was only sections 4.1.1 through 4.1.5. There is a second half to Chapter 4. I've talked about this in class. For some reason, the second half of Chapter 4 is probability. I don't know why. Chapter 5 goes into the rest of trigonometry, which we started in Chapter 4, but for some reason, in the middle there, we just take a quick break for probability, which we're not going to do, so we're skipping it. So here we are coming into Chapter 5. So we start Chapter 5 with The Streets of San Francisco, Section 5.1. So, while traveling around the beautiful city of San Francisco, Juanisha was climbing one of their steep streets, and she went on one that has a slope angle of 31.5 degrees, according to her guidebook. So when she started walking 100 feet along the surface of the street, so actually, measuring on the street, you could measure that with like a Fitbit or something, she wanted to know like her change in altitude, how high she was up in the air versus where she started. So she drew this diagram down here. Now, I'm not going to make you work on this exactly because we should already be able to see we have no idea how to solve for that change in y. Because you might think, okay, we've got an angle, we can use tangent, but tangent is only going to compare this change in y and this change in x. It's not going to touch that 100 feet. We now have a problem. Tangent does not touch the hypotenuse. We have absolutely no idea what to do in a problem like this because tangent leaves us with 2 variables. We could say tangent of 31.5 equals change in y over change in x. That would give us the slope, but it wouldn't give us either x or y, so it kind of leaves us stuck. Now, technically, there is a way we could do this. It's a very long, complicated process in which we solve for the slope of 31.5, find out what that slope is, then taking that slope, create a separate, similar triangle, use the Pythagorean theorem to solve for the hypotenuse of that triangle, and then apply the scale factor to find out what the scale factor is between that similar triangle and this one using the hypotenuses and comparing them, and then applying that scale factor to the delta y of the small one and finding out the delta y of the big one. That sounds like a really, really long, terrible, complicated process that we're not going to do, but it's technically what we could. So what this brings us to is, there's gotta be an easier way. And the answer is yes, there is. So that's what we're going to go into. We're not going to spend our time on that horrible mess I just described. We're going to try and figure out what the easier way. So here we've got a diagram that we can use to kind of get started on this idea, where we've got a half equilateral triangle. If we remember, we've worked with this before. It's got that 60-degree angle and that 90-degree angle, and this is half of an equilateral triangle. So if we kind of reflected that over, we could see that it would make a full equilateral triangle with all 3 sides having a length of 6. But since it's just half, we get the hypotenuse for one has a length of 6, and the base is a length of 3. Same thing for the one on the bottom. Has a hypotenuse of 2 and a base of 1, where the base is half the length of the hypotenuse. So, if we want to find that change in y, well, we've got 2 different ways we could do this. I'm going to let you pause here to figure it out, so try and figure out two of them. I'll tell you what it is after the pause here. So go ahead and pause now. Okay, so the two ways you should have found to do this are, one, the Pythagorean theorem, using 6 squared minus 3 squared equals that height squared, or same thing with 2 and 1. Alternatively, you could have used tangent of 60 degrees. So tangent of 60 degrees would be equal to x over 3. So x would be equal to 3 times the tangent of 60. Same thing with 1 and 2. We would get tangent of 60 degrees equals x over 1. So x is just equal to tangent of 60 degrees for that one. Then we get to part B. What is the ratio between our change in x, or our base, over the hypotenuse for each of these triangles? And it says, why must these ratios be equal? I'm going to let you pause again so you can think through this, and then I'll give you the answer in a minute. So take a second and pause now. All right, welcome back. So what you should have found is that the ratio should be 1/2. That 3 is half of 6, 1 is half of 2, so we should get a ratio of 1/2. It says, why must these ratios be equal? Well, they're the same. They're slope triangles in the same line, so they have the same slope, which means, as we found out last chapter, they have the same angle. So they both have that 60-degree angle. They both have a 90-degree angle, so they should have angle-angle similarity. Since they've got that angle-angle similarity, they've got to have the same side length ratios. So that means that those ratios absolutely have to. Okay, so now we've got part C here, where it says find the lengths of BC and AC in the triangle below. Show all your work. Well, we've only got one angle and one side length, and that side length is the hypotenuse. We're right in the same boat that we were at the very beginning, except it's 60 degrees, and just in that last problem, we saw what that ratio is between the base and the hypotenuse for 60 degrees. So let's just start with that one. I'll let you go ahead and work through that. So go ahead and pause here and work through that, see if you can figure it out. Okay, so you should have found that length BC should be 3.5, half of 7, because if you remember from the last slide, the base was always half of the hypotenuse. We had 3 going to 6 and 1 going to 2. So for a hypotenuse of 7, it's going to be half that, so 3.5. Now that you've got that, I'll let you go ahead and use either the Pythagorean theorem or tangent to figure out the length of AC, and then I will see you in the next video for some wrap.